All right, so this is the second part of coordinate geometry. The last thing we did on this actually really wasn't any coordinate geometry. We're going to actually do that mid-segment thing with some coordinate geometry. So let's just review briefly. I'm just going to draw just some random triangle like this and like this. All right. And so what did we say the mid-segment was? Well, if you took the midpoints of any two sides of a triangle, let me do this. One more time. Boom, boom. Let's put a little dot right there. Okay, what did I just put dots there for? What were those dots? It was the what of the sides? Yeah, but just the dots themselves. Where was this? It was the middle. It was the mid what? Midpoint, right. This is a midpoint. This is a midpoint. Now, what I did is I connected the midpoints together, all right, to make this line segment right there. So this is the last thing we talked about on Friday. What was this segment called? It connected the middle, the midpoint, so it's called the what? The mid-segment, all right? What we're going to do. Now, when we talked about the mid-segment, we didn't really use coordinate geometry at all, okay? We just did a triangle, showed you where the midpoints were, and we said there was two things that was true about that mid-segment, all right? Do you remember what was true about it? Let's do this. Let's call it A, B, C. We'll call this D and E. What do we know about the mid-segment? We knew two things. Did you write it down? If you took notes Friday, it's probably written down, isn't it? Yeah. Fab, what's it say in your notes? There's two things. Okay, it's parallel to the third side, okay? So this DE right here, the mid-segment, is parallel to the third side. It's the side that's not connected, all right? It's this, right? So this BC right here is not connected. So we could write it like this. We could write that DE, line segment DE, is parallel to line segment BC. That's the symbol right there. I think somebody asked me last time. Apparently we don't talk about that much. But anyway, that's the symbol for parallel. All right, those two up and down lines. So that's one thing that's true about this. There's another thing that's true about DE and BC. We actually took this, we copied it, made it a different color. We put it along here and we put it along here. So how many of these DEs can fit on BC? Two of them. That's right, two of them. Two of these DEs can fit on BC. So tell me about the length of DE compared to the length of BC. It's half of it. That's right. So the length of DE is equal to 1/2 the length of BC. Notice I didn't put any line segment over top of it because when I don't do that, we're talking about the measure of it, the length of it. All right. So the length of DE is half of the length of BC. So a quick little example, if BC was, 12, what if BC was 12? If you know that DE is the mid-segment, you could find what DE is, and what would it be? It would be 6. It's pretty easy, isn't it? Yeah. Let's go the other way. What if I said DE was, 5? What if DE was 5 and I asked you to find BC? What would that be? It would be 10. Just like that. Everybody good with that? And they're parallel to each other, all right? DE and BC are parallel to each other. So that's pretty important too. So what do you know about this angle and this angle right here? They're equal to each other. Parallel lines cut by a transversal, these are corresponding angles. So this little angle right here and this little angle right here are equal to each other, all right? What about this angle and this angle? They're also equal to each other, aren't they? Again, parallel lines cut by a transversal, the corresponding angles are equal. So we go way back, right? It's been a little while since we did that parallel lines. I don't know if it was way back. I forget what chapter. Was it chapter 3? I don't know. It might have been. So maybe the last chapter. That this angle and this angle are equal to each other. All right, so that's kind of nice. All right, that's enough of that. I'm not going to say any more about that. But the example that we're going to do has a lot to do with that right there. So actually, you know what I want to do? I want to come over here and grab this thing right here. Let's make sure. Yeah. Make sure that one's, oops, it's not what I wanted. Wanted this. All right, there we go. So what I'm going to do is now we're going to incorporate that mid-segment theorem into coordinate geometry. Okay, this is when you do graphs, that's coordinate geometry. Anytime you see a graph like this, you're thinking in your head, this is coordinate geometry. All right, so they tell you a bunch of stuff. Well, that's what they tell you. It says find the midpoints. They refer back to example 1, and I'll do this. So they refer to example 1. Let's write the stuff that we know from example 1. We know point A was -7, 1. I think we did this on Friday. B is 1, -5. And C is 7, 3. All right, so what we're going to do is let's plot or graph. A lot of times in coordinate geometry, we use the word plot. Plot the point, okay? Feb? We're going to do something different with it, though. Okay, we're going to do something different. It's the same looking triangle with the same points, except we're going to do something a little bit different. What did we do with it on example 1? We found the slope and the distance, didn't we? Okay. So this time what we're going to do is we're going to find the midpoint, okay? So let's plot it first, okay? Plot, that's the word that we're going to use. We could say graph, that's fine. If I say graph a point, that's fine. It completely makes sense, but we're going to say plot the points, okay? So point A is -7, 1. So there's -7, there's +1. That's point A. And again, we did this on Friday, but we're going to do something different with it, though. Point B is 1, -5, so 1, -5. 1, 2, 3, 4, 5. That's point B. And then C is 7, 3. So 7 goes to here, and then 1, 2, 3. That's point C. What are we going to do with those 3 points, do you think? Connect them. And we're going to make a what out of it? Triangle out of it. That's exactly right. So let's do that. All right, so there we go. It should look familiar. You probably already have it in your notes, but we're going to do, again, something different with it. What we're going to do is, number 1, they actually ask you to do 3 different things with this. Let's change colors. Let's go back to white. So the first thing they ask you to do are find the midpoints of all the sides. Find the midpoints. Actually, they just asked you to find the midpoints of 2 sides, of AC and BC. All right? So let's do that first before we do the other stuff. Friday, we talked about the slope, and we talked about, what was the other thing we talked about? The distance formula. So this is that third thing, okay? We spent a lot of time in that chapter, whatever chapter it was, talking about this stuff. So this is a little bit of review, but I'll write it down. Do you remember the formula for the midpoint? It's actually a point, so we write it as an ordered pair. Do you remember this? How do you find the mid of something, the middle of something? What do? You take it and you divide it by what? 2. So the first part of this, I put over 2. What do I do with the midpoints? I do something with the x's and I do something with the y's. What do I do with the x's? I add them together. To find the midpoint, you add the 2 x's together, and then you add the 2 y's together. Is this coming back to you? It should. We spent a lot of time on this back when we first studied it. So there's the formula. What we're going to do is we're going to find the midpoints. The midpoint of AC. So let's just look up here. I guess we could look here, right, and figure out what the points are. But I already got them listed. So AC. So this one and this one. I want to find the midpoint. Can somebody open the door for me?
No, it's a door.
Oh, okay. So what are we doing? Find the midpoint. I'll put midpoint, and I'll put a little AC right there so I know what I'm finding the midpoint of. You understand my writing here? This is midpoint, and then a little AC, so I'm finding the midpoint of AC. There's A, there's C. Let's do it. It's an ordered pair, so I put parentheses and a comma, And then I always put over 2, and I always put over 2. Okay? Now, what do I do with the x's? Add them up. Very good. So, what am I doing? I'm doing AC. I'm doing the first one and the third one, okay? So I add up the x's. What do I get? -7, what? +7. Okay? And then what's the y's on AC? It's 1 and 3. So it's 1 plus 3. Let's see what I get. -7 plus 7 is 0. 0 divided by 2 is 0. So my first point is 0. The second one was 1 plus 3, which is, everybody, 4 divided by 2 is 2. So what is the midpoint of AC? It's 0, 2. That's right. So I'll tell you what, let's do this in a different color. Let's put a, and it looks like it should be. Doesn't it? See, it crosses right here. 0, 2 lies right on the line. Doesn't it look like halfway between A and C? Absolutely. I might have been able to guess it just by looking at it, but you don't want to do that, right? Because it's not always going to come out nice and even like this. All right, so 0, 2. Oh, by the way, Ty, congratulations. Got a state champion here. And that's very impressive. It really is. It's pretty awesome for a school of our size to have a state champion right in your class. You didn't know you were among greatness, did you? In here. All right. No, that's awesome. Congratulations. It's really good. All right, let's do the other one, BC. So I'm going to do BC right here. Why do you think they're asking me to find the midpoints? What do you think they're going to do with this? Why do they think they asked me to find the midpoints of two sides of a triangle? Because we're going to find the what? We already said we're finding the midpoints. What are we going to find? We just talked about it like 5 minutes ago. What are we going to do? I'm going to find the midpoint of this side, find the midpoint of this side, and then what can I get out of those two midpoints? The mid-segment. That's it. Find the mid-segment. That's what we're doing here. Okay, we're trying to find the mid-segment of this triangle, all right, between sides AC and BC. That's what we're doing. But we're doing it with coordinate geometry, okay? All right, so let's do one more midpoint. So this time we're going to do the midpoint of what? Of BC. So I'll put a little BC right here. This is exactly how I want you to do it on a test or a quiz. You can do that, yeah. All right, so midpoint of BC. That's what I'm just so I know which ones I'm finding. All right, let's scooch this down a little bit. So now which ones are we doing? We're doing, tell you what, let's get rid of this arrow. Let's get rid of this. So now we are finding BC, this one and this one. All right, so what do I do first? I put my parentheses, put my comma, and then I put my over 2. It's the very first thing I do before I start even thinking about putting points in here, okay? All right, so now let's do it. What do we put in the first one? Okay, 1 plus what? Good, because we're adding the x's together. And then we add the y's together, so what do we put there? -5 plus 3. It's very important that you keep the negatives. If it's negative, you make sure you make it a negative. We can do this in our head. What's 1 plus 7? 8 divided by 2 is 4. -5 plus 3. What's -5 plus 3? Is it 2? It's -2 because the bigger number is negative. All right, so it's -2. What's -2 divided by 2? -2 divided by 2. It's -1. 2 divided by 2 is 1, and it's a negative, so it's -1. So what does this mean? What did I just find there? I found the midpoint of what? BC. So where is it? 4, -1. So I go 1, 2, 3, 4, -1. Look, it crosses exactly where it should. Because I used a graph paper kind of thing, and I made sure it was pretty accurate. So yeah, it falls exactly where it should. Now, what do you think I'm going to do with those 2 points? Well, not through them. I'm just going to connect them. Okay, I'm just going to connect them. And what is that yellow line segment now? That's called my what? It's called the mid-segment. So there must be 2 things that's true about the mid-segment. Agreed? It must be what? Okay, it's half of AB, and it's also parallel to AB. Okay, let's see if they do that. They do all this. So let's find, Actually, they don't do the parallel part. They just do the length part. So we'll just do the length part. We could do the parallel. How would you be able to show that this, what we're going to call this DE? Call this D and E. How could I show that DE is parallel to AB? What would I have to do with the coordinate geometry stuff? How do I know if two lines are parallel? If their whats are equal? The slopes are equal. That's right. Okay. If the slopes are equal to each other, if this slope is equal to this slope, then they're parallel. Okay? Everybody with me? We could just count. Let's do that without doing all this stuff. Let's just count. Let's find the slope from D to E. Rise over run. So let's rise. So we go down how many places? 1, 2, 3. So we rise -3. And then we're here and we go what? 1, 2, 3, 4. So it's -3/4. That's the slope of that. Let's see if AB has the same slope. Let's count. We're going to go all the way down to what? Here? All right, so let's count. That's 1, 2, 3, 4, 5, 6. Down, so it's -6. Wait a minute, that's not the same as that. But what do you think is going to happen? Yeah, exactly. 1, 2, 3, 4, 5, 6, 7, 8. So it's 8. What's -6 over 8? It's -3 over 4. So what's the slope of DE? -3/4. What's the slope of AB? -3/4. So what's true about those two? They're parallel. So do you agree with me now that those two are parallel? Sure. All right. They don't ask you to do this in this particular question. They could ask you, show me why they're parallel to each other. Yeah. You didn't write it. All right. Take a picture.
You can't write the graph.
You want me to smile?
I take one too. You can smile.
All right. Let's do it. The one other thing that they ask you to do, and that is to find. What did we say? What did we say should be true about the lengths of those two? DE should be what? Half of AB. So how do we show that? How do I show? I'm just going to get rid of, well, I'm going to keep this there until you take the picture. You already got it? Okay. You should be writing it down, but that's okay. Oh, the graph thing? Okay. All right, so now, how do I find the length of DE? I use the distance formula, right? If I want to find out how long line segment DE is, I use the distance formula. We did this on Friday. So this big D right here is the distance. This little DE just means I'm finding the distance of DE. Everybody got it? Do you remember on Friday? What's the distance formula? It's that big old square root. This is coming back to you? It should. I'm subtracting, right? You only add, right, and you square it, but you only add on the midpoint, okay? It's the other two, the slope and the distance. You subtract the x's from each other, okay? So this is going to be x1 minus x2. This is going to be y1 minus y2. Now, that's my formula, but let's actually find the distance of DE. What did we say the point was? Remember we had it written down? What is that point right there? It's 0 what? 0, 2. And what is E? 4, -1? Okay, so now let's do it. Put a square root, big old square root. I always like to put all this stuff first before I start throwing numbers in. Okay, I call that the shell of the formula, right? We're going to write that down every single time. So now what do? We take these 2 points and we subtract the x's from each other. So what is it? 0 minus 4, or you could put 4 minus 0. It doesn't make any difference. All right, and then we subtract the y's from each other. What's that? 2 minus -1. All right, let's do a little bit in our head, okay? I don't need to write down every single step. So 0 minus 4 is -4. When you square a negative, what does that always come out to be? A positive. So it doesn't matter if that's a negative or not. If I'm squaring it, it's always going to come out positive. So I don't have to worry about the negative. So what's 4 squared? 4 times 4. 16. That's right. So that's 16 plus, what's this going to be? 2 minus -1. What happens here? Minus, minus. Right, add the opposite. Okay, so this would be what? 3, right? What's 3 squared? That's 9. Got a little carried away with that square root. Let's bring it in a little bit. All right, this actually works out kind of nice. So what is this? The square root of, what's 16 plus 9? Adding 9 is easy. Here's what I do. Here's what I do when I add 9. I think this is close to 10, right? And we could add 10. That's super easy to add 10. What's 16 plus 10? It's 26. But then you take one away because we didn't add 10. We added 9. And that's what? 25. What's the square root of 25? It's just 5. So that's DE. That right there is 5. What do you think AB should be? What do you think it's going to be? What do you think AB should be? It should be 10, right? Let's see if it actually is. So let's do the distance of AB. Let's see if it actually is. So big square root, parentheses squared plus parentheses squared. All right. And what's this? What did we say A was? -8, 1, because it's off my screen up here. And then B was, -7, sorry. -7, 1. And what was B? It was 1, what, 5? -5? 1, -5. Okay, so let's do it. Let's do distance. So what do we do? Subtract the x's from each other. -7 minus 1. Let's subtract the y's from each other. That's 1 minus -5. Okay? -7 minus 1 is -8. Again, I'm squaring it, so I don't care about the negative. So what's 8 squared? 8 times 8, 64. Plus 1 minus -5. Minus negative is plus, so that's a 6. What's 6 squared? 36. 64, 36 is 100. What's the square root of 100? What times itself is 100? It's 10. Isn't that what we said it should be?
Yep.
Absolutely. And we just it's kind of a proof. It's kind of a coordinate geometry proof, all right? Kind of. And we just showed that the mid-segment is half of the third side. And that's what they wanted you to do on this example, okay? They wanted you to see that it does work out that way, okay? You didn't just have to believe me. Remember up here, I just told you on Friday that these two things were true, right? And you're like, okay, you're the teacher, I guess you know. But that's not the way we need to think all the time. Now, sometimes things are a little too hard and difficult to prove. This one wasn't that hard to do, all right? So this one just showed that both of those things that we said were true. They have the same slopes. Remember that -3/4? They have the same slope, so they're parallel. This one is half of this one because that's 5 and that's 10. And there we go. We kind of showed that theorem, all right? Let's see what else. We got one more example and we'll be finished. We got 10 minutes, so I think we got time. It's very similar to what we just finished doing, all right? We're going to use the same, tell you what, let's drop this right here. We're going to use the same points, but they're going to do something different. Let's see, what are they doing? Oh, okay, I see what they're doing. You know what I'm going to do? Let's do this. So I don't have to redraw. Oh, that's kind of a mess, but that's okay. I can get rid of the stuff that I don't need. Let's copy that whole thing. Let's put that right there. I'll get rid of some of that junk here in a second. Let's okay. All right, so let me get rid of some stuff. Let's get rid of, oops. All right, bear with me. It just takes me a minute to get some of this done. Okay, we got all that. Okay, we found the midpoint of 2 of the sides, didn't we? Let's find the midpoint of, what's the one side we didn't find the midpoint of? Find the midpoint of AB. BC, we found the midpoint. It was at E. Okay? We found the midpoint of AC. We didn't find the midpoint of AB. So that's what that's what they want you to do right off the bat. So, what do we got? We got -7, 1 for A, right? And then for B, we've got 1, -5. So this time, we're not going to find the slope. We did that earlier. We're going to find the midpoint. So how do you find the midpoint? It's an ordered pair. So you put the parentheses and the comma, and what do? You divide by 2 for midpoint, and then you add the x's together. So let's add the x's together. Negative 7 plus 1. Let's add the y's together. 1 plus negative 5. What do you get? This is going to be negative 6 over 2. This is going to be negative 4 over 2. Going quick because of time. And let's figure out what that is. That's negative 3, and this is negative 2. So what is the midpoint? We just found the midpoint of AB. It's at negative 3, negative 2. Let's see if it actually works, okay, and it actually fits on here. 1, 2, 3, 1, 2. Look at that. Perfect. Right there. And we're going to call that point F. Everybody with me on that? So now I found the midpoints of all those. So guess what? This isn't the only midsegment. See that DE? That's not the only midsegment of this triangle. What's another midsegment? Well, DF or FD. That would be a midsegment, wouldn't it? What's another midsegment? FE, that's right. Because I'm connecting midpoints, right? So really, I have 3 midsegments of that triangle. I don't just have one. So what do you think is true then? DF has got to be parallel to what? DF. It's parallel to... It connects these two sides. What's the one side it doesn't connect? DF connects this AC and AB. What does it not connect? BC. So DF has got to be parallel to what? BC. Everybody see that? So this one right here and this one right here, they should be parallel to each other. Okay, what's the other one we didn't do? FE. FE must be parallel to what? AC. Everybody got that? And FE, the distance of FE must be half of the distance of AC. And the distance of DF has got to be half of BC or CB. All right? It looks a little confusing. You guys have already given up on me because you're starting to talk while I'm still teaching. Up here. All right, we only got like 6 minutes left, so let's just bear with me on this. So what they want you to do, I'm only going to do one of them, okay? It's just redundant to do the rest of them. Let's do DF and BC, or FD. I keep saying DF, but FD, BC. All right, everybody see that one? So I'll tell you what, let's just change colors just so I can refer to them instead of the letters. Let's just let's go pink. Come on, pink. There we go. All right, see the blue one and the pink one? Can you see the difference between the colors? Yeah. Yep, it works. So the blue one and the pink one, that's what we're going to say, all right, just to make it a little easier for us. What do you think we're going to have to do? I want to show that that's the midsegment. How do I show that FD is the midsegment is one of the midsegments of that triangle? Well, I show that it's parallel to the third side. We already know that, well, actually, yeah, we did. This is negative 3, negative 2. So we know the midpoints, right? How do I know that that's an actual midsegment? Well, if it's parallel to this side, then it's a midsegment. So what are we going to do? Let's see if they're parallel. So we're going to find the what? If I ask you to show me that they're parallel, well, what do we find? The what? Come on, I already gave you a hint. Slope. Okay, we're going to find the slope of the blue one, of FD. So find the slope, that's M, of FD. How do we find the slope? We haven't talked about it today, but we did talk about it on Friday. We did it several times. Instead of we could just count, but let's do the actual arithmetic. So it's the change in y over the change in x, right? So you subtract the y's, put it on top, subtract the x's, and put it on the bottom. You should be getting used to these formulas now. We've done them a lot, all right? So the blue one, what are my y's of the blue one? Well, I got a positive 2 and a what? Negative 2. So it's 2 minus, is it 2 minus 2? No, it's 2 minus what? Negative 2. And now we subtract the x's. Give me a sec. Subtract the x's. So here's one x. Here's the other x. So it's 0 minus negative 3. So what is the slope? 2 minus negative 2? Same as 2 plus 2, which is 4. What's minus negative? Positive 3. So what's the slope of the blue one? It's 4/3. Marge, you have a real question, or what is it? You got to go to the bathroom? I can't hear you. You're mumbling. A couple weeks, I think. All right. Now, we found the slope of the blue one. What should also have the same slope as the blue one? What in here? All these line segments. What should also have the same slope? BC, the pink one. Okay? So let's find the slope of the pink one, BC. It should be the same as the blue one, right? If it's a mid-segment. Let's see if it actually is. What is this point, by the way? What is point C? That's 7, 3. Is that right? 1, 2, 3. Yep. All right, so let's find BC. So we subtract the y's. So 3 minus negative 5. Subtract the x's. 7 minus 1. Let's see what we get. We get 3 minus negative 5 is 3 plus 5, which is 8. 7 minus 1 is 6. Always reduce it. 2 goes into that 4 times, 3 times. Check it out. They have the same slope. All right? So now they have the same slope. What's the relationship between the lengths of the blue one and the pink one? Now, the lengths. We already said they're parallel to each other because they have the same slopes. What about the lengths of them? It's half. That's it. This one, the blue one, should be half of the pink one. Everybody see that? All right. How do I show that? I'm just going to erase this because it just keeps everything on the same page. Let's find the slopes. I'm going to do it kind of quick because we're running out of time. The slope of the blue one, which is FD or DF, whatever you want to call it. All right. We just did distance not too long ago. So we should have that down pretty good now. What's the distance of the blue one? What do we do? Subtract the x's. 0 minus negative 3. Subtract the y's. What's that? 2 minus negative 2, right? This is positive 3 squared, which is 9. This is 4 squared, which is 16. Take the square root. Look what happens. We get the square root of 25, which is what? 5. So the length of that blue one is 5. What's the length of the pink one? What should it be? 10. Let's just do it really quick just to make sure, and then we'll be finished. That's all we're going to do. So the distance of BC. So what do we do? Squares, add squares. Okay, of BC, let's subtract the x's. 7 minus 1. Let's subtract the y's. 3 minus negative 5. 7 minus 1 is 6. 6 squared is 36. This is 8. 8 squared is 64. Take the square root. That's the square root of 100. What's the square root of 100? It's 10. So, sure enough, the blue one is 5. The pink one is what? 10. Is the mid-segment half of the third side? Yes, it is. Now, on this example, they actually do the other side as well, AC and FE, but I think you got the gist of this, so we're not going to do that. So, you do have some homework. That's right, homework. That's correct, I did not. So 1 to 16. So this is section... Oh, I didn't give any homework Friday, did I? So this is A. So it's 4-7A. And 1 to 16. All right, there's your homework right there. Just write it down. It's 4-7A, 1 to 16. That's your homework. It's due tomorrow. So get that done. What are we doing on Friday? Did you look at your lesson plans?
We're doing a test.
We're having a test on Friday. So that's it.